All right, so we are going to go ahead and start with number 1. Number 1 says, use given conditions to write an equation for the line in point slope form and in slope intercept form. So the values that we are given is that it passes through the point 8, negative 6 and is perpendicular to the line with this equation. So the first thing we're going to do is we're going to try to find the slope of the new line we're looking for. So for that, all you're going to do is you're going to take the slope of this one, and you are just going to flip it into the reciprocal. So that's going to make it 3. And it's going to be a negative 3 because you're also going to flip the signs, because there's technically a plus sign in front of this one, and you're just going to flip that one too. So now when you rewrite it out, you should have y equals negative 3x plus b. Because for this new line, we're not sure what b is yet, because we can't use this one because this is its own line. So now what we're going to do is we're going to try to find b. So we are going to take these points and plug it into this equation. So what we're going to do is we're going to do negative 6 equals negative 3, 8 plus b. And then we're going to solve for b. So then we get negative 6 equals negative 24 plus b. So then when we take the 24 and we put it onto that side, we are going to get a positive 18 equals b. So now we know that b equals 18, so then we can rewrite it down here. So it's going to be y equals negative 3x plus 18. And that is going to be your slope-intercept form. So now, to write it in point-slope form, we're going to use these points from earlier. And I'm going to go ahead and erase this. So we have a slope-intercept form in the red. And so now in the green, we're going to find the line in point-slope form. So it's pretty much the same equation. You have y equals a negative 3x plus 18. But instead of the 18, we're just going to plug in for these two. So you can just get rid of the 18 for there because we don't need it. And then you're going to use this negative 6, and it's going to become positive when you put it into the equation. So you're going to get y plus 6 equals the slope, negative 3, and then x minus this 8. And then there you go. That's going to be, in the green is going to be your line and point slope form, and in the red is going to be your slope intercept form. Okay, so then we'll go ahead and start with number 2. Number 2 says, use the given conditions to write an equation for the line in point slope form and general form. So it's going to pass through this given point, which is 2, negative 9, and it is perpendicular to the line. Is perpendicular to x minus 5y minus 6 equals 0. That 0 should be on the other side of the equal sign. So the first thing we're going to do is we're going to find it. We're going to find the slope of this equation. So the first thing you're going to do is you're going to take, you're going to try to get the y and the x on different sides. So first you're going to have the x minus 5y minus 6 equals 0. And then what I would do to try to keep everything positive is I would move the 5y to the other side. So now you're going to have x minus 6 equals 5y. And then what you're going to do is you're going to divide both sides by the 5. So then you're going to get y equals, you're going to get y equals 1/5 x, because we're just taking this 5 and putting it on that side. You can, if you really wanted to, you could leave the x over the 5, but it's just easier to find the slope if you write it like this, and then you're gonna do negative 6/5. Now, this isn't what it's asking for. This is the slope-intercept form. This is not what the question's asking for. This is the slope-intercept form of the given line. So now that we have that, we can find the slope, which if it's perpendicular to this line, that means all we're gonna do is we're gonna take this number, and like we did in equation 1, we're gonna take the reciprocal of it, which would be 5, because now instead of the 5 being on the bottom, we're gonna put it on the top. And this has an imaginary plus sign in front of it, so we're also gonna change that to a negative. So the slope, or m, equals -5. So now that we have that, we can start to write it in the point slope form. So we're gonna go ahead and erase all of this stuff, because we did all that to find the slope of our line. And now what we're gonna do is we're going to plug it in. So first we have the y equals -5x. And then we are going to, like in the last one, to find the point slope form is we're going to take the given values. So like here you have the -9. So you're going to have y plus 9 equals -5x minus 2. And this is going to be your point slope form. And now we're going to try to find the general form. So for the general form, all you're going to do is you're just going to factor all of these out and distribute any of the coefficients. So for this one, you're going to end up with y plus 9 equals, so the -5 goes to the x, so -5x, and then the -5 goes to the -2 to create a plus 10. And now you're going to try to get all of the variables, so the x and the y, on one side, and then all the numbers on the other side. So you're going to bring this guy over here, and you're going to take the 9 and put it over there. So you're going to get a y plus 5x equals a -1. And there you go. This is the general form of the line. And then here in the blue is going to be your point slope form. So let me go ahead. And then now we're going to start on number 3. Okay. So number 3 says, find the average rate of change of the function. And then I'll write the function. So that's going to be f of x equals rad x. And it's going to be, oops. It's going to be from x1 that equals 25 to x2 equals 49. So for this one, you're going to have to know your average rate of change formula, which is, let me just pull it up. So your average rate of change formula is FB minus FA equals B minus A. So for in this case, the B and the A, you can substitute with x1 and x2. So let me go ahead and rewrite that. So this is pretty much going to say f of x2 minus f of x1 equals x2 minus x1. So we can go ahead and set that up down here. So what this means, the x2, means that you're going to plug this in everywhere you see x. So that's going to give you, I'll do these in different colors. So for x2, we'll do it in green. So that's going to be radical 49. And it's going to be minus. And then for x1, I'll put that one in red. And minus radical 25. And that's going to be over. So now we just plug in this value normally down here. So it's going to be 49 minus 25, because then you're just taking the x1 and putting it down here. So now we can go ahead and solve this out. So radical 49 is 7, minus radical 25, which is 5, and then 49 minus 25, which should give you 24. And then when you even that out, it's going to be 2 over 24. And then when you simplify that, you get 1 over 12. And then 1 over 12 is your final answer. That is the average rate of change of the function from x2 to x1. Okay, let me go ahead and do number 4. Number 4 does have a graph in it, so I will try my best to make a pretty graph. So number 4 says, begin by graphing the absolute value function of f of x equals the absolute value of x. Then use transformations of this graph to give the graph the given function g of x. And then it says g of x equals negative 3 x plus 1 plus 5. And then it is going to ask for what transformations are needed to obtain the graph. So we'll go ahead and start with that. So first of all, you see here how it's an x plus 1. That means it's going to be a horizontal shift. So horizontal shift of negative 1. So that means it's going to be going to the left 1 unit. Okay, and then the next one we have is the plus 5, which is a vertical shift. And the vertical shift is going to be 5, and it's going to be up 5. So up 5 units. And then finally, we have this negative 3, which is going to be a reflection and I believe a vertical or a horizontal stretch / shrink. So it's going to, the negative sign is what makes it flip. So it's going to have a reflection over the x-axis. So that's the negative. And then the 3 part is going to give it a horizontal, I believe, shrink. So the reason that it's for the negative 3, the reason that it's over the x-axis and the horizontal is because it's attached to the x. See how the 3 is right next to the x? So if it were attached to the g of x, then that would make it a reflection over the y-axis or a vertical shrink. So now that we know all of this, I'm going to go ahead and erase, and we are going to graph our function. Okay. So I'm going to go ahead and try to make a graph. And then we'll go up to 5, and we'll go down to negative 5. And for this one, you are going to have to know your parent functions. So if you knew the parent function of the square root of x, you would know that it's going to look like this. So on a normal graph, it would be, let me do the axes in blue. So these would be your axes, and the graph would be like this. It's very similar to an x squared function where it would be just a parabola, but it's an absolute value. So it's more sharp in the angles. So now that we have all this information, we'll go ahead and graph our function. So we know that, let me make more lines. Okay, so what we're going to do is we're going to find the origin. So the origin of it is going to be that negative 1. So we go right here to negative 1, and then plus 5. So we're going to go 1, 2, 3, 4, 5. So this is our origin. So from here, after you find the origin, you do have 2 options. You can translate every single point if you wanted to, and you can graph it like that, or you can make a table of values. Personally, I prefer a table of values. So that's what I'm going to do right here. So we have our x and our y. So what you would do is you would plug in x values into the x and then see what you get for y. So I'll go ahead and start with the number 2. So if I plug 2 into the x, I'd get 3. So the 2 plus the 1 would be 3. And that'd be times negative 3. So that'd be 3 times negative 3, which is negative 9, plus 5, which gives you negative 4. So with that, And then I'll plot all of these points in red. So you would go to 2, so that'd be 1, 2, and you'd go to -4. 1, 2, 3, 4. So you know that point would be right here. So let's go with another point. We'll do 1. So if we plug 1 into here, I can erase all this stuff too to make it easier to see. So if we plug in the 2 right here, or sorry, the 1, we're going to get 2. So then the 2 times the -3 is -6. So from this, you get -6. And then plus the 5 would be -1. So then you can go ahead on your graph and find where this is. So x is 1, y is -1, so you're going to go down 1, and this would be your next point. And you're just going to keep doing this until you feel like you have enough points to make an accurate graph. So we'll go ahead with 0. You plug in 0, you get 1 times -3 is -3, plus 5 is 2. So then you get 2. So you're going to go to 0, 1, 2. That would be your next point. So now we know that that this is the origin. So we already know if you plug in -1, what the outcome is going to be, which would be 5. So you can do -1 and 5, and then I'll continue the graph down here so we don't go through it. So we will go ahead and do -2. So you plug in -2, that's -2 plus 1 gives you -1, but with the absolute values, that just turns into a normal 1. So then you get 1 times the -3, which is -3, plus the 5, which you get 2. So if you go -2 on the x, so 1, 2, and then you go up 2, so 1, 2. So then you get this. And then we'll do 2 more points so that we can match it on this side, on the right side. So we'll go ahead and do -3. So -3 plus 1 gives you a -2. If you absolute value it, you're going to get a 2. So then the 2 times the -3 gives you a -6, plus the 5 gives you a -1. So then you're going to go -3 for the x, so 1, 2, 3, and then you're going to go down 1. And then we'll do one more, we'll do -4. So you put the -4 into here. So you'd get -4 plus 1, which would give you -3. -3 times, and then you absolute value it, so you have a +3. So the +3 times the -3 will give you -9, and then plus the 5 would give you -4. So then you do 1, 2, 3, 4, and then you're going to go down 4. So 1, 2, 3, 4. And now you have enough points to make an accurate graph. So you're going to go ahead and just connect all of your lines or all of your dots. And that is the graph for g of x. Okay, that was number 4. So we will go ahead and move on to number 5, which is also a graphing question. So number 5 says, use transformations of the graph f of x equals x cubed, and to determine the graph of the given function, h of x equals -x plus 6 cubed. So x cubed is another parent function that you're going to have to know. So let's say it was like this. This is your graph axes. So it would kind of look something along the lines of kind of like this, sort of. It's an odd function, so it's gonna not be symmetrical on both sides, but that's kind of the gist of what it looks like. So we can go ahead and make our graph. Or yeah, let me move it closer here. So we can go ahead and make our graph. So the first thing you're going to want to do is label your graph. Well, the first thing you can do is find where your center is going to be. So if we look here, there's the x plus 6. So our center is going to be a -6 for the x. And because there's no transformation regarding the y, it's just going to be a 0. So we can go ahead and start making our graph. Actually, we'll just do it like this. Here we go. So we have, we'll put, I guess, -8 over here, and we'll do it by 2s. So -6, -4, and -2. And then for the y-axis, we'll do it by 2's as well. So 2, 4, 6, and then -2, -4, -6. So now that we know the center is at -6, 0, we're just going to put it right there. And then just like in the example before in number 4, we're just going to plot or make a table of values and plot some points. So we'll go ahead and start, and we'll do them in blue this time. So we can go ahead, and you're going to want to pick points that are close to the center so that you know, like, it's going to be easy to graph. So we'll start with -8. So if we plug in -8 to here, it's going to be -8 plus 6, which gives you a -2. And then -2 to the power 3 is -8. So it'd be -8 times a negative, so you'd get a +8, which would be like all the way over here. And then we have the -6, so now we'll do -4. And we won't do -6 because we already have it, we know it's our center. So we have a -4, and if we plug that into the equation, you get -4 plus 6, which gives you a 2. And then 2 cubed is 8, and then you would multiply it with this negative, so it'd be -8. So you know this one's going to be all the way down here. And then you would go ahead and graph it. Now you could do like -7 and stuff in here too, and -5 if you want to get more precise points. But really, if you know how the graph's supposed to look like this, and you know it's kind of curvy like that, you can kind of just put it in like that. Because you know it's supposed to similarly look like this. The transformations for this one, so if she were to ask you what the transformations were to get from f of x to h of x, you would say that it has a, I'll go ahead and erase the graph, and then we can do the transformations. So if she wants you to give the transformations, you do that. For graphing it, you can either graph it via transformations or you can plot points. So we'll go ahead and list off the transformations. So the first one is going to be this, the x plus 6. So that is going to be a horizontal shift. And it's going to be -6. So that means it's going to be going to the left direction 6 units. Okay, and then this negative sign, or I can do it in a different color. Let me do this. And then this negative sign just means that it's going to be a, what do you call it? A flip over the x-axis. So, or a reflection over x-axis. So you would just flip it, and that's just the negative sign. So those are really the only transformations that you have in that equation. Okay. So then we'll move on to number 6. Let me clear this. So number 6 says, find the domain of the function, and the function is f of x equals the square root of 14 minus 2x. And then what is the domain of x? And it says to give it an interval notation. Interval notation. So what we do know is that this equation does have to be greater than 0. Otherwise, you'd get that I imaginary number. So what you would do is you would write it here. You'd have 14 minus 2x is greater than 0. And then you would just pretty much solve for it. So you would square root both sides. So you'd raise it, you'd square and square. So then you get 14 minus 2x is greater than 0. And then you would subtract 14 from both sides. So you get -2x is greater than -14. And then what you're going to do is you're going to multiply both sides by a negative sign. So you get 2x and 14. Now it's very important when you multiply or divide by a negative, this sign does flip. I don't know why, but it does. It always does when you multiply or divide by a negative sign. And then what you're going to do is you are going to divide both sides by 2. So then you're going to get x is less than 7. So now you know, so it can be any number that the only restrictions on it is that it has to be less than 7. So what you're going to do, so that means it's negative infinity, comma 7. Oh, and it can be, sorry, it can be greater than or equal to 0. So you do have that equal sign in there all the way down. And that's why it's in the brackets, because it's including 7. Because this can be equal to 0, the radical. It can be equal to 0, it just can't be a negative number. So it's greater than or equal to 0. And then for negative sign, or sorry, for infinity signs, whether it's negative or positive, it's always a parentheses, because you can never technically include an infinity. It's always a parentheses. Okay. So now we'll go on to number 7. So given functions f and g, find f minus g. So it says f of x equals 8x minus 2. And then g of x equals 6x minus 5. So to find the answer, and it does give you multiple choice on the study guide. So this one on the study guide is a multiple choice. I'm not sure what it'd be on the test, but we are just going to solve it normally. We're trying to find f minus g. So what we're going to do is that I'll write f in blue, and then I'll write g in green to start off with so that it makes more sense picturing it. So we got 8x minus 2 minus, and then you're going to want to put it in parentheses, the g, so that you make sure you distribute this negative sign correctly. And then you have 6x minus 5. So the first thing you're going to do is you can just rewrite this part, and then you're going to distribute this negative sign to both values. So you're going to get negative 6x and a positive 5. And then you're just going to combine like terms. So you'd combine these two and these two. So when you combine the 8x and the negative 6x, then you would get 2x. And then when you combine the negative 2 and the positive 5, you get a plus 3. And so that would be your answer. It is just 2x plus 3, which is letter B, the answer B. Okay. So now for number 8, again, I'll make it, oops, not erase it, G. So you got G in green, and we'll do F and blue. So you got f of g of x equals, so for this x, you would plug in g. So you have f of x plus 2 plus that 5. So right now, there's nothing to distribute. There's just an imaginary 1. So you can imagine distributing it if you like. So then you have 5x plus 2 plus 5. So you get 5 of x plus 7. And so that's going to be the answer for A. Now for number, what's this? C, letter C, we have, I'll rewrite this. I'll go through B just to re-clarify it because it got a little confusing. So B is G of X and then X. So G will be green and F will be blue. So you're going to plug the second one into the first one. So what you're going to do is you're going to have G of f of x, which equals, so you're going to have the 5, x plus 5, and then plus the 2. So then when you solve this out, you are going to distribute the 5 to the x and to the 5. So you're going to have 5x plus 25 plus 2, which, and then when you combine like terms, you get 5 of x plus 27. And that's the answer for B. Okay, so now we can move on to C. And then I am uploading this video in Canvas. So if I'm going too fast, don't worry, you'll be able to go and rewatch it. I'm just trying to get the video to be as short as possible so that when people are watching, it's not taking forever. Okay, so then we have C. So then we're gonna have f of g, 1. So you're gonna solve this one pretty much the same way as before. But when you get your final answer, you're just gonna plug 1 into it. So we'll go ahead and do the green and the blue again. So you have f of g of x equals, so you're gonna have 5x plus 2 plus the 5. We're just plugging g into f. So then you'd have 5x plus 2. Again, you can imagine there's an imaginary 1 right there and distribute it out, if that makes more sense to you. Plus 5. So then we're going to have 5 of x plus 7. So now what you're going to do is this 1 from before, you're going to plug it in. So you would technically have a 1 right there. So you're just going to plug 1 in for everywhere you see x. So it would go right here. So then you're going to have 5 of times 1 plus 7. So then you're going to have 5 plus 7, which gives you 12. And that's the answer for part C. And then I'll go ahead and do D. Okay, so D is g of f, 1. So for this one again, I'll do a green and a blue one. So you're pretty much doing the same thing you did for B, but then again at the end, you're going to plug in 1. So then you're going to have g of f of x equals, so then you'll have the 5, and then the x plus 5, and then the plus 2. Because you're just plugging the f of x into the g equation everywhere you see an x. So then you're going to distribute that 5, which is going to give you 5x plus 25 plus 2. Then you combine like terms to get 5x plus 27. So now you're going to take this 1 from before and plug it in everywhere you see x. So that'd be right here. So then you're going to get a 5 times 1 plus 27. So then you are going to get a 5 plus 27, which is 32. And that is the answer for part D. Okay, I'll go ahead and do number 9. Okay, so number 9 says, express the given function as a composition of two functions f and g so that h of x equals, and then I'll go ahead and write it. So this is what h of x is, the given equation. And then it says to write it so that it is written like this. So this one is also multiple choice on the study guide, but I don't know if it's going to be multiple choice on the test or not. So for this one, you are just going to have to figure out kind of mentally in your head, if you were to plug G into F, what would you get? So first off, what I would look at, so we'll make F blue and G green. So F, I could see, you kind of just have to think about it and figure out what would make the most sense. So I would see this part, the 6x minus 3, I would see that as being plugged into something, the whole equation, if that makes sense. So I would see G, because G is the one getting plugged in, because G is the second one, so it's getting plugged into F. So I would see G of x as the 6x minus 3. So then for the f, I have to think, okay, if I were to plug g into something, how would I get it on the bottom? So then f of x, you would think would be 1 over x. Because if you were to plug this, into every instance that you saw x in f of x, then you would get 1 over the 6x minus 3, which is the h. So that answer, so this in the red, this would be your answer, your final answer. F of x equals 1 over x and g of x equals 6x minus 3. And that is letter D on the study guide. Okay, so then we'll do number 10. Okay. So it gives you this function. It says f of x equals x to the third minus 3. And it says it is 1 to 1. So this is a 3-part question as well, I believe. Yeah, so it says the first one is A. So it's asking you to find f of -1. So that is the inverse equation. So how we do inverse equations is that you are just going to replace the x and the y, and then you're going to solve back for x again. So as we know, f of x is the same thing as y. So you would have, your normal equation would be like this. This is this equation, but just written with the y instead. And then you are going to switch these two, the y and the x. So when you get that, you would have x equals y to the third minus 3. Okay? So then what you're going to do is you're just going to solve for y, my bad. You're going to solve for y to get y by itself to get an equation that looks similar to this one. So first thing you're going to do is you're going to add 3 on both sides. So you're going to get x plus 3 equals y cubed. And then you are going to cube root everything. So you're going to cube root this, and you're going to cube root that. So your final answer should be y equals the cube root of x plus 3. Okay. So, and then B says to verify that your equation is correct by showing that f of, hold on, I'll rewrite this. So let me go ahead and write down what f1 of x, or f -1 of x equals y equals 3x plus 3. I'll go ahead and erase all of this stuff. So these are your two equations up at the top. Here, I can rewrite this nicer. Equals x plus 3. And this is for all of x. So all of x. So now what you're going to do to verify the equation is correct is you are going to, it says to do this. So f of f -1, well, I can do it in blue, of f -1 x. And then you're going to have to do the other one too. So, and then you're going to have to do it the other way. So that'd be f -1 f of x. So if both of these check out, that means you did it right and you find the right inverse equation. So first we'll do this one. We'll do the one on the left first. So you're going to have, so that means that for every instance of x in the f of x equation, so for every instance of x in the black equation, you're going to plug in the blue equation. So that is going to be, so first thing we have is the x cubed. So you would plug in 3, or sorry, there we go, 3x plus 3 cubed minus 3. So then to solve this out, so this 3 cancels out the radical portion. So then you are going to be left with x plus 3 minus the 3 from before. So then you are going to have just x. So if both of these are the same, then that means that you did it correctly. So for this one, it's x. I'm just writing that up there so we remember the answer we got from that one. So I'll go ahead and erase this. So that means that if this equation also equals x, that means we did it correctly. So I'll go ahead and write it so. So that means for every instance of x in the blue equation, you're going to plug in the black equation. So we have, first we have the radical, we have 3. And then we have an x, so we're going to plug in x cubed minus 3. And then we have the plus 3. So we're going to go ahead and just try to simplify everything. So we can break up this parentheses like before. So 3, and then you're going to have an x cubed minus 3 plus the 3. And these two are going to cancel out. So then we are going to be left with cube root 3 x to the cubed, which equals x. And there you go. Both of these equal x. So that means that you did it correctly, and that's how you verify that your inverse is correct. So your inverse answer is this. And then the work I did down here is how you prove it. Okay, so we'll go ahead and move on to number 11. Okay, so number 11 says, gives you a function. F of x equals x plus 7 cubed. So this one is also asking you to find the inverse of that equation. So we'll go ahead and do that first. So we are trying to find the inverse of f of x. So again, what we're going to do is we're going to rewrite it. So y equals x plus 7 cubed. And then we are going to switch the y and the x. So we're going to have x equals y plus 7 cubed. So now we're going to go ahead and solve for y. So the first thing we're going to do is we are going to cube root both sides. So then you're going to end up with a cube root x equals y plus 7. And then you are going to subtract 7 from both sides to get cube x minus 7 equals y. And that is the inverse function that we just found. So I'll go ahead and write it up here. Equals, well, the y is the f of x part, so we really only have to write the part with the x. So that is going to be cube root x minus 7.
Not that bad. It could be worse.
So now that we have that, it wants us to check it like we did before. So to do that, we have to do the two equations. So we have f, and you plug in the inverse. And then we have the other one, which is the inverse. And then you plug in f. Okay. So we'll go ahead and do the one on the left first. So we have our first x, which we're going to plug in the blue equation for. So we have the parentheses initially, and then we're going to plug in the blue equation. So we have x minus 7, and then the minus 7. Oh, sorry, not the plus 7 cubed. So then we can go ahead and break down these parentheses. So it's going to be 3 rad x minus 7 plus 7 cubed. And then we can go ahead and cancel out these two 7s. So then you're going to get left with a 3 rad x cubed, which equals x. So this one up top on the left equals x. So just like before, we are going to write it down in red so we remember what it equal to. And we're going to erase this. And then we are going to go ahead and do the opposite equation now, the one on the left. So first we have 3 rad, and then we have our first x. So in the parentheses, we are going to plug in x plus 7 cubed. And then we're going to finish the blue equation, minus 7. So the first thing we can do is that these two, this 3 and this radical, cancel each other out. So then we're going to have x plus 7 minus 7. And then again, you can break down these parentheses. So you're going to get x plus 7 minus 7, which is just going to leave you with an x, just like the equation on the left. So this means that since they both equal the same thing, that means that that you did your inverse correctly. So this is your inverse equation, and then everything we did on the bottom is how you prove it. Okay, so we're going to start with number 12. Okay, so it says find the distance between the pair of points. So it gives us 2 points. So the first point is negative 5 rad 5 comma 2. And the second point, I'll put in green, is negative 4 rad 5 comma 4. Okay, so it wants us to find the distance of the 2 points. So we're going to have to use the distance formula. So the distance formula was radical. It's x squared minus x1 squared plus y squared minus y1 squared. Or sorry, y2, not y squared. So we'll go ahead and make this equation, the black equation, we'll make that our x2 and our y2. And we will go ahead and make the green equation x1 and y1. So we're going to go ahead and plug it into this equation. So we have the x2, which is negative 5 rad 5, minus the negative 4 rad 5. And then I'll do the distance equation in red so that it's not all the same color and it makes more sense. Negative, parentheses, then you square it. It's going to be plus the y2, which is 2. And that's going to be minus the green, which is 4. And then you are also going to square that. So then you're going to have the distance equals. So now in this parentheses, we are going to combine like terms in the x parentheses. So since they're both a rad 5, you just combine what's on the outside. So this turns into a positive 4. So you'd combine the positive 4 and 5, so you would get a negative rad 5 squared. And then you would get a plus 2 minus 4, which is negative 2. I'm going to square that.
Yeah.
And then, so then you're going to get negative rad 5 squared is 5, and that's going to be plus negative 2 squared, which is 4. So D equals rad 9, which is 3. And number 12 is multiple choice, and that's A. All right, so we are going to go ahead with number 13, which is finding the midpoint of a line segment given 2 endpoints. So first, we have negative 3, negative 1. And then I will also put the other points in green so that it doesn't get confusing. So, and then it's going to be negative 8 over 3 comma negative 3 over 5. So first thing you're going to have to do is remember your midpoint formula. So midpoint equals x2 plus x1 over 2, and then y2 plus y1 over 2. So we'll go ahead and find the x's first. So first thing you're going to have to do is decide which equation or which set of points is going to be your x1 and y1, and then which one's going to be your x2 and y2. So we'll go ahead and make the ones on the left x1 and y1, and then we'll go ahead and make the ones on the right x2 and y2. So then you're going to plug it into your midpoint formula. So your x2 is the negative 8 over 3. So you have negative 8 over 3, and it's going to be plus the negative 3 from the black set of points. So then to combine them, the first thing you're going to have to do is convert the 3 into a fraction with 3 on the bottom. So you're going to have your negative 8 over 3, and now it's going to be a minus, because these two, you can just convert it to a minus. So you're going to have minus. So what you would do is you take the 3 times 3 to find the top. So you'd have a 9 over 3. And then what you're going to go ahead and do is you're just going to combine everything on the top. So you are going to end up with negative 8 minus 9, which is negative 17. And then that's going to be over 3. And now what you're going to have to do is you're going to have to simplify this equation. So to do that, you are going to take your negative 17, your negative 17 over 3, and it is being divided by 2. And so then you're going to go ahead and do your copy, change, flip, which is 17 over 3, and it's going to be times 1 over 2. So your final answer for that one would be you just multiply these and these, so you get negative 17 over 6. And so that's what it's going to be for your x's. So I'll go ahead and raise up here and plug that in. So you have a negative 17 over 6. And now we'll go ahead and find the y equation. So what you're going to do is you are going to plug it into your midpoint formula. So your y2 is negative 3 over 5, and that's going to be plus the y from the black equation, so that is a negative 1. So now, just like before, we are going to have to make sure that both of the denominators are the same so that they combine more easily. So you're going to have a negative 3 over 5, and then again, like last time, these two just convert into a negative sign. So you're going to have a negative 5 over 5, because you would multiply the 1 by 5 to get the top. So now what you're going to do is you are just going to combine the top. So a negative 3 minus 5 is a negative 8. So you're going to end up with a negative 8 over 5. And just like before, this is really ugly. So we are going to go ahead and make it a little better. So you got negative 8 over 5. And then you have your divided by 2. And then you're going to copy, change, flip. So you have a negative 8 over 5 times 1 over 2. And then you're going to multiply across the top and the bottom. And you're going to get negative 8 over 10. And then this can simplify if you divide the top and the bottom by 2 to negative 4 over 5. So then you can erase this up here. And you get your negative 4 over 5. And then that's your final answer on the study guide. It is answer C. And that's it. It's just going to be a set of points for that one. So let's go ahead and move to number 14. So number 14 says, write the standard form of the equation of the circle with the given center and radius. So it says the center is 5 comma negative 2, and the radius is r equals 6. So your standard equation for a circle is the x squared plus y squared equals, equals r squared. So what you're just going to do is you're going to plug in the points to find the equation. So you would take this 5 and it would become an x minus 5, because the signs are going to flip for those points, squared, plus a y plus 2, again that sign's going to flip, equals the r squared. So that would just, since r equals 6, that would be 6 squared, which is 36. And then that's it. That's the whole problem. This is the standard form of the equation of the circle with that given center and radius. Okay, so now we are on number 5. So number 5 is you're going to find the standard form, the center, the radius, and you're going to graph it. So let me go ahead and write down what we have. So that's x squared plus y squared minus 2x minus 8y minus, oops, minus 19 equals 0. So the first thing you're going to want to do is you're going to want to get it into two equations like it was before in number 14, where you have the x in a number squared and then the y in the number squared. So you're going to want to group together the like terms. So let's group together all the x's. So we have x squared minus 2x plus y squared minus 8y equals 19. And now we're going to have to do the completing the square to find the c value, or the missing value, so to speak. So that is going to be c equals b over 2a, the whole thing squared. So we'll go ahead and do the x's first. So the x's, if you plug it in, so if you plug in the a, it's a 1, because the 1 in front of the x squared is a 1. So you would have 2 times 1, and the b is a negative 2 squared, which gives you negative 2 over 2 squared, which gives you negative 1 squared, which gives you 1. So for your x equation, you would get x squared minus 2x plus 1. Now we'll go ahead and do it for the y's. So for the y equation, the a is a 1, and then the b is a negative 8, and it's squared. So then you are getting negative 8 over 2 squared, which is negative 4 squared, which is 16. So now for your y, you have a y squared minus 8y plus 16. So then we can go ahead and erase this because we don't need it anymore. And that's going to be equal 19. But you got to remember, whatever you do on the left side, you have to do to the right side. So this 1 and this 16, we're going to have to add to the right side. So it's going to be 19 plus 16 and plus 1. So then what you're going to do for the x is you're going to factor it. So you're going to have an x, should be minus 1 squared. And then you're going to have plus. And then for this one, you're going to factor it. So it's going to be 1 minus 4 squared. And then you're just going to add up the 19, the 16, and the 1, which is going to give you 36. So this is your standard form of the equation. So I'm going to go ahead and write it up at the top. So we can just hold on to it. So I'm going to go ahead and write it in blue. So we have the x minus 1 squared plus y minus 4 squared equals 36. Now with this information, we can go ahead and find our center and our radius. So what you're going to do is, for the center, these numbers in here. So it's a 1 and a 4, because remember the signs flip. And then for the radius, It's whatever by itself on this side square rooted. So the square root of 36 is 6. So now that you have all that information, we can go ahead and graph it. So I'll go ahead and make my graph. And we'll go up to 10. Actually, we'll do it like this. We'll do 10. Then we'll do 8, 6, 4, 2. And on this side, we'll do 2, 4, and 6. This side we'll do -2, -4, -6. And then down here, we'll do -2. Okay, so for your center, for this one, we'll go ahead and graph it. So it's going to be at 1, so it's going to be about right here. And then you're going to go up 4. So this is going to be your center right here. Now for your radius, or for the rest of your circle, you know that it's 6 away from anything else. So 4 plus 6 is 10. So we go right there. Oops. There we go. My bad. Okay. So then from here, you go up 6 to the right 6, which would be the 5. No, I'm sorry, that'd be 7. So right here. And then this down 6 would be the -2. And then you minus 6 from 1, that would be the -5. And then you go ahead and you just combine or connect all of your points to get your very poorly drawn circle. Let me see if I can make that a little better. And there you go. That's going to be your circle for the graph.